Assalamu alaikum. My name is Salma Muhammad Osman. I'll be your instructor for Principles of Computer Networks for this semester. These are my contact information. I would like one of you to be my link with you and to create a Telegram group in which we can discuss different matters of the course and for you to ask questions and me to answer them. The course objectives are four main objectives. The first is for you to understand the principles of computer networks, and the second is for you to understand networking theory, and the third is for you to understand specific implemented protocols on TCP/IP protocol stack. Lastly, to understand the principles of network security. The course will cover an introduction to networks, the physical layer, the data link layer, the medium access layer, and the network layer, the transport layer, the application layer, and the network security principle. We have three textbooks. The first is Computer Networks by Andrew Stewart Tannenbaum, the 5th edition. This will be our main book. Computer Networking, a Top-Down Approach by James Course, 7th edition, and it's very useful to understand TCP/IP protocol stack. Last but not least, Cisco Internet Working Handbook, 3rd edition. This is a rather older reference. It was published in 2003, and despite it's an old book, but it's very useful when it comes to principles of networking and internetworking. So I highly recommend it. As for grading, we will have weekly writing assignments. All of them will count for 10% of your final grade. There will be a midterm examination counting for 20% of your grade, and there will be a comprehensive final exam counts for 70% of your grade. There might be weekly tutorials that actually will be extra 10% of your total grade. I'll see if this is possible to arrange with the faculty and get back to you on this. Before we start our course, I would like to set some ground rules. Rule number one, when I say something, I mean it. That means whatever I say, you have to believe that I will do. Rule number two, I have zero tolerance policy. I don't have to deal with any nonsense whatsoever. Rule number three, deadlines are deadlines. You can't push them, you can't stretch them, you can bend them, they're dead. Rule number four, your grade equals your grade divided by number of people you have shared your assignment with. That's to say, if you shared your assignments with 4 others, your grade will be divided by 5. Nowadays, taking into consideration that you will be using actually AI, I expect to have at most 3 different versions of every writing assignment. That means your grade will be divided by a huge number of people. I advise you to personalize whatever you're getting from the AI. Rule number 5, no sad stories. I don't care to hear your sad stories, and they will change nothing in the end result. In conclusion, I'm not a nice person. I am as nice as you are committed and disciplined. This lecture is an introduction for networking, during which we will discuss computer networks, applications of networks, network topologies, network components, and network hardware. A network, a computer network, is 2 or more computers connected together. These computers can be geographically located anywhere. The connection means can be wired or wireless, physical or virtual, as we shall see. There are 3 main types of networks: Local area networks, LANs, these cover a relatively small geographical area. Wide area, that is metropolitan area networks. This covers a whole city. And wide area networks, WANs, and these covers from what ranges from a whole country to the whole globe. Why do we need networks? We need networks for information sharing. That means to access remotely files, databases, and to be able to store and retrieve information remotely. It's also needed for sharing, for searchability purposes, where you can search the information in total disregard of its physical location, such as websites. It's also for resource sharing, whether these resources were hardware like printers, file servers, disks, okay, tape readers, or software such as application software. It's also used for communication, like emails and instant messaging and message broadcasts. It's used for remote computing, where you can actually execute your code on a remote computer and get the result. And for distributed processing, like grid computing, where multiple processors are hardwired together to work on one task simultaneously. What we mean with the network topology is the actual physical setup of the network, how the network is wired actually. We have multiple topologies. The first one and the oldest one is the bus, where all the devices are linked to a single cable. And this is the base of what we shall discuss as broadcasting networks. Then the star and tree topology. Star topology is a topology where there is a central point to which all computers are connected. And any communication between any pairs of computer will have to go through this intermediate node. Tree topology is an extended star topology with multiple peripheral central points connected to a main central point. And this will actually reduce the amount of traffic in the network tremendously, because dividing the devices in a network to smaller groups will help to decrease the amount of traffic that is transferred on the network. The ring topology, on the other hand, is where computers are actually arranged in a ring. Every two computers are linked together, and there is a frame that passes through the network. When one of the hosts want to communicate, you will hold that frame and send the information. That's why it's called the token ring. This frame is a token. And rings can be single rings or dual rings. In single rings, information flow is in one direction only. In dual rings, information flow can be in both directions simultaneously. Lastly, the mesh topology, where every computer is linked to every computer in the network. This is usually used in WANs to interconnect LANs, and is really expensive, but it's preferable when actually it's mission critical, when the networks connected together are working on a critical mission. What are networks composed of? Roughly, the physical media, the interconnecting devices, the computers, the networking software, and the applications. The physical media can be actually hardwares, such as coaxial cables, copper cables, fiber optics, or can be wireless signals in the air. There are different network devices that connects computers and connect networks to networks, such as hubs, switches, routers, wireless access points, and modems. And we will discuss each of these when the time comes throughout this course. Computers on a network can either be clients or servers, where servers provide certain service, printing service, database, web pages, and the clients will request across through the network, send request to the servers, and the servers will reply to these requests with whatever was asked from them. There are different applications that runs on top of networks, and this is the part you should be familiar with, like emails, websites, e-commerce, Amazon, ePay, news groups, internet telephony, WhatsApp, Telegram, Booking, video conferencing, Zoom, Google Meet, group chats, instant messengers, internet radios and television, and a lot of other applications that runs on top of networks. As for network hardware, networks can be classified either based on transmission technology or based on scale. And that's to say what geographical area they can actually cover. Based on transmission, we have two categories of networks, broadcast networks and point-to-point networks. Broadcast networks is where a single sender can send to multiple senders or to multiple receivers or to all receivers within the network. And there are three possible addressing. The address can be unicast, that's from single sender to single receiver, or broadcast, that's from a single sender to all receivers, or multicast, that is from single sender to multiple receivers. Point-to-point networks, on the other hand, the communication link exists between every two pairs of computers, and the message is sent directly from the sender to the receiver. When we talk about scale, we can actually see 5 different types of networks. A PAN, a personal area network, that covers 1 square meter. A LAN that covers anywhere from 10 meters to 1 kilometer. A metropolitan network that covers a whole city. A wide area network that can cover a country up to a continent. The internet that covers the planet. A personal area network is where your personal devices are connected. Your laptop, your wireless mouse, your wireless keyboard, your wireless printer, or your earpods, your phone, and your smartwatch. A LAN, on the other hand, can be wired or wireless. Wired, such as switched Ethernet, that means Ethernet cables going through a switch, and this we will discuss later. Or 802.11, which is IEEE standard for wireless communication. IEEE is International Electrical and Electronic. Okay, I lost it now. Lakin we will come to it later. For man, the man was basically built on top of the cable networks infrastructure, TV cable networks. The TV cable networks were networks that distribute TV services to the houses. When internet came, the companies that run these networks use this infrastructure to distribute internet services as well. And it usually covers the whole city. We don't have them around here. Again, they were very common in Northern America and Europe. For the WAN connects different networks across what we call a subnet, where a subnet is a collection of routers connected together with communication link. This link can be physical link or virtual link. Physical links such as a lease line and virtual links such as frame relay technology. And we will discuss both of them later in this course. In the WAN, the communication will go like a sender will send the packets. The packets are the information unit in a wide area network. They send the packet to the first router connected directly to it. And this router A here, can decide to go through router C or router D. Apparently, it chose router C. And router C can go through router E or router D, and it chose router E. And router E is directly connected to the receiving host. Here we can see that a router has to make the decision on which direction or through which other router it's going to forward the data from source to destination, from sending host to receiving host. These decisions are made either statically, that means preset, or dynamically, that means for each packet individually, or for each connection individually. And all of these options are going to be discussed later. When it comes to the internet, the hardware is actually a collective number of networks interconnected together. We can commonly say that the internet is a collection of local area networks connected through a LAN, through a WAN. A WAN is subnets plus hosts, where a LAN is cable plus hosts, and the internet is internetworks, interconnected networks. The WAN and the LAN are usually privately owned, but the internet has different owners, different technologies. Your reading assignment for this week will be Chapter 1, Section 1.1 from Computer Networks by Andrew Stewart Tannenbaum. And your writing assignment will be History of Internet in not more than 2 pages. Thank you for listening and see you next Tuesday, inshallah. As I've said, I will attach the books to this lecture, and I'm waiting for you to choose one of you to be your link with me and to create the Telegram group. Thank you very much.